Okay, here we are with some examples to review for trig. All right, looking at this first example, we have an angle of reference here in the corner of 38 degrees. The side across from it would be known as the opposite side. The one across from the 90 degrees is our hypotenuse. And what we want to solve for is that opposite side. So the trig ratio that uses the O and the H, if we think of our SOHCAHTOA, if I can write that in here, SOHCAHTOA. All right, then I think the one that we need is the sine. So we could do the sine of 38 degrees would equal opposite over hypotenuse. And then to get x by itself, it's being divided by the 12.3, so we can undo that by multiplying both sides by 12.3. And then depending on how your calculator works, for me, I can just put 12.3 multiplied, and then I'm going to hit 38 and then hit my sine. For some of you, you'll just do sine and then the 38. So as I said, I put in 12.3, I'm multiplying, I'm going to do 38 and then do my sine and hit equals. I get 7.6 approximately for that. So x is approximately equal to, the dot above, 7.6 centimeters. Okay, looking at the next one, we are trying to find hypotenuse in this case. So it's either going to be SO or CA, and based on that 54 degrees, this would be opposite. That means the 7.3 that we have is adjacent. So it is the the cos, the the cos of 54 degrees is going to equal adjacent, which is 7.3, over hypotenuse, which is the x. Now I can't solve for x when it's on the bottom, so I'm going to undo it just like we did, get rid of that fraction in the previous example, but this time instead of multiplying by a number, I'm multiplying by x. That gives us that the x times the cosine of 54 degrees, cosine of 54 degrees, that looks a little mutated, but bear with me here. That's equal to 7.3. And then to get x by itself, it's being multiplied by the cosine of 54 degrees. So we're going to divide both sides by the cosine of 54 degrees. And cosine of 54 degrees on this side. That gives us that x will be equal to, and then in my calculator I do 7.3 divided by, you either do cos 54 or in mine I do 54 cos, and then hit equals. I got 12.4 approximately there. 12.4, and meters is our units this time. Okay, looking at the next one, hypotenuse, I don't know anything about, nor do I care. My x, the 3.6 is opposite to it, and that means my 4.9 is adjacent to it. So the opposite and adjacent works with tan, so the tan of x is opposite 3.6, and I could make that a capital X, but I just have a generic little x. Okay, now this time to get x by itself, it's attached to the tan, and I said we can never leave the tan without something beside it right after it. To undo the tan, to get tan away from the x, that's when we do the tan, the inverse function of tan, or shift tan, or second function tan, on this answer. So that 3.6 divided by 4.9 comes after our tan inverse, our inverse function of tan, because we're performing that function on this number. Okay, so that's a little communication piece there. So on my calculator, I'm going to go 3.6 divided by 4.9 and get my answer there, which is a decimal answer, and then I'm going to hit shift tan. Other people, you can just do shift tan and then it'll come up with brackets. Make sure the 3.6 divided by 4.9, that entire thing is in the brackets. So I got about 36.3 degrees as my angle there. And just make sure you are in degree mode. If you're not getting the answers I'm getting, it could be because you're not in degree mode on your calculator. You're going to look for a D or a DEG on your display to indicate you're in degree mode. All right, so solve. This one says solve. Remember, it means find all missing side lengths and all missing angles. Based on what we have here, I already have a 90-degree angle, a 20-degree angle. We can get angle C quite easily using that fact that the angles in a triangle add up to 180 degrees. So we can do 180 minus the 90, which is 90, and then take 20 off of that, which would be 70. So angle C is 70 degrees. I'm still going to use my 20 degree as my angle of reference, just because it was my original there in case some people started at a different spot. This side is opposite to it. This would be my hypotenuse, and this would be my adjacent over here. And I'm going to label my adjacent with a lowercase letter c and my hypotenuse with my lowercase letter a, so that everybody who reads my solution knows which side is which. Side A is hypotenuse. If I want to solve for side A and I know my opposite, I could use the sine of 20 degrees would equal opposite 2.4 over that hypotenuse, which is lowercase letter a. Now notice that when we solved and the variable was on the bottom, what ended up happening over here was that x was equal to 7.3 over the cos of 54 degrees. Really, the x and the 54 are switching position. So if you want to use that as a shortcut here, if you think about that as a shortcut, your a and your sine of 20 degrees really are going to end up switching positions, and a is going to end up equaling 2.4 divided by the sine of 20 degrees. So a is approximately, let me put that into the calculator, 20 degrees, if I can read my writing there, and I get about 7.0 in terms of my value there, and that's in meters. Okay, the last one we have to get is our C. We could use the Pythagorean theorem. I'm going to actually just use the opposite adjacent. I'm going to use tan on that one, just because I find it's a little quicker than using the Pythagorean theorem. So the tan of 20 degrees would equal opposite, which is 2.4, over the adjacent, which is C. And remember, we can do a switcheroo here. C will equal 2.4 divided by the tan of 20 degrees. And put that in the calculator. And I get 6.6 approximately as my answer for that. And that will be in meters as well. So we've solved for all missing side lengths and angles there. We solved that triangle. Moving along here. Okay, we have 3 triangles here, A, B, and C. None of them have 90-degree angles, so that means we have to use sine law or cosine law. If I look at the information that's given in A, I notice that I have an angle and the side across from it. So that will complete one of the sine ratio components. So I could go like sine of angle E over little e and completely fill that in. And then further to that, I'm looking to solve for angle F, and I know side F. So based on that, I want angle F. I'm going to put the sine of angle F on the top over side F, which is 15, and that has to equal the sine of angle E, which is 57 degrees, over side E, which is 23. All right, now to get sine F by itself, that's the first step. I'm going to undo the divide by 15 here by multiplying by 15, so that gets rid of that. Multiply that by 15, and then what we have is sine of angle F being equal to this calculation here. The sine of 57 degrees divided by 23 times a 15. And you can just put the 15 out front if you want to avoid the brackets. I'm going to put that in my calculator. 57 sine times 15 divided by 25. I get 0.5032 approximately. Now, I don't always write this next step that I'm writing in right now but just so that you have a number to compare it to. I get approximately that. Now I'm leaving all the digits in my calculator, and to get my F by itself, remember we're doing shift sign or second function sign on that answer that you have in your calculator. So I'm leaving all my digits there, and then I'm just hitting shift sign, and I get about 30 degrees there, approximately. So angle F is approximately equal to 30 degrees, 30.2 if we go to 1 decimal place. All right, if I look at G, H, and I as a triangle, I notice that I do have an opposite, like an angle in the side opposite, But when it comes to my other two sides, I don't have a complete ratio. I don't know angle I and I don't know angle G. So when I fill this in, I don't have one complete. This one, I want the X, but again, I don't know what it is. So we have a whole, whoops, redo, there we go. We have a bunch of stuff, but we don't have enough to use the sine law. What we do have is a side, another side, and the contained angle, the angle between it. So this is a perfect sine law or cosine law case. When you know two sides and the contained angle, we want to use that sine law or cosine law. I keep saying sine, I mean cosine. So I want to find side X, or side H really is what that is. I'm going to label my sides with the lowercase letters here just so I don't get confused. So I want to solve for side H. So H squared is going to equal I squared plus G squared, or G squared plus I squared, minus 2GI, or IG, times the cosine of angle H. So I've set that up so my H and my H are like the bookends, and my I's and J's are, or G's are in the middle here. So H squared, and I forgot my square on the I. So I squared would be 28 squared plus 41 squared minus 2 times 28 times 41 times the cos of 133 degrees. And then I just put that all in my calculator in one entire step here. And when I do, I get about 4,030.87 roughly. Again, I'm keeping all my digits in my calculator. I'm going to square root that answer, and I get H being approximately 63.5 meters. Okay, now looking at this next triangle, this also is a perfect cosine law question because we have all three side lengths and we have no angles. So it will not work to try and use the sine law with this one. I want to solve for angle J. That means when I set up, I'm going to use a different color this time. When I set up my equation, I've got to put side J by itself because I want angle J to be in the equation. So I have L squared plus K squared minus 2 times L times K times the cosine of angle J. So that these guys match up here. All right, so J squared, 5.8 squared, is equal to L, which is 4.3 squared, plus K, which is 6.2 squared, minus 2 times 4.3 times 6.2 times the cosine of angle J, which is what we have to get by itself. Okay, so there's a bit of work to be done here. This 5.8, I'm going to do a little bit of a switcheroo here. It's a plus on this side. It's going to come to the other side and become a subtract. The other piece here, which I'm going to do a switcheroo with, these are all attached through multiplication and it's a minus. I'm going to switcheroo by adding all of that. So what I end up with is the stuff underlined in red comes to the other side, and we have 2 times 4.3 times 6.2, and I could have multiplied that all out, times the cosine of angle J is going to equal that 4.3 squared plus 6.2 squared. And then that's going to be subtracted by 5.8 squared. Okay, so let's tidy this up. 2 times 4.3 times 6.2. That gives me a 53.32 cosine of angle J. And on this side we have 4.3 squared plus 6.2 squared minus 5.8 squared. And I got a 23.29. Now at this point, to get my cosine of J by itself, I'm going to divide both sides by 53.32. So that will give me what the cosine of J is equal to. So my cosine of J will be equal to 53, approximately equal to 0.4368. Now there's more digits there, I've just rounded that to 4, and then I'm going to shift cos, second function cos. So J is approximately equal to 64.1 degrees.